All right, let's get right into it. For more than a decade now, there's been one building that stands not just as the tallest in the world, but as this kind of monument to an ambition that, honestly, no one has even come close to matching. We're talking, of course, about the Burj Khalifa. But the real question is, why? Why has its record been so completely untouchable? To really get why it's such a big deal, you gotta look at this one number, 62%. See, when the Burj Khalifa opened its doors back in 2009, it wasn't just a little bit taller than the last record holder, Taipei 101. No, it was an absolutely mind-boggling 62% taller. This wasn't just breaking a record, this was rewriting the rulebook entirely. So yeah, that's the big question we're tackling here. In our age of constant, relentless innovation, why has this one incredible achievement stood totally unchallenged for so long? What is it that makes building taller just so ridiculously difficult? For most of human history, this whole race to the sky was, well, it was a slow-motion race. I mean, the Great Pyramid of Giza held the title for nearly 4,000 years. Then you had cathedrals taking over for centuries. The 20th century, sure, it sped things up with icons like the Empire State Building, but the progress was always step by step. A few meters here, maybe a few dozen there. Increment. And this chart? Man, this really puts it into perspective. The World Trade Center, it was about 9% taller than the building before it. The Petronas Towers, about 8%. And then, bam, the Burj Khalifa comes along with that insane 62% leap. It didn't just raise the bar, it blasted the bar into orbit. So you have to ask, how on earth was this even possible? What kind of technological magic trick made such a massive jump in height happen all at once? Well, the answer lies in a totally revolutionary new design. It's called the buttressed core. This was the brainchild of the building's structural engineer, a guy named Bill Baker. This design, this idea, it was the secret sauce. It was a completely new way to distribute the building's immense weight and handle the powerful wind forces so efficiently. Yeah, the easiest way to picture it, just think of a tripod. You've got these 3 wings, or legs, that brace this super strong hexagonal core in the middle. This simple concept gives the entire structure a kind of stability that nobody had ever achieved before on this kind of scale. But of course, it wasn't just the core. The whole project was just one engineering first after another. We're talking a foundation so massive it had to be drilled deep into the desert sand, the invention of the world's most powerful concrete pumps just to get the material to the top, and even the shape itself was designed to cleverly confuse and break apart those powerful high-altitude winds. Okay, so they proved it could be done. The technology was there. The floodgates should have opened, right? You'd think we'd see even taller buildings popping up everywhere. Well, that's where the story gets really, really interesting. All right, let's meet the main contender, the Jeddah Tower in Saudi Arabia. The goal? To be the very first building to smash the 1-kilometer barrier. Construction actually started back in 2013 using a pretty similar design. But then, in 2018, everything just stopped. And to this day, it hasn't started up again. And look, this wasn't a one-off thing. The Dubai Creek Tower, halted. The Azerbaijan Tower, totally canceled. China's ambitious Sky City, canceled. You start to see a pattern here, right? A graveyard of ambition. Clearly, there's a lot more going on here than just engineering. Okay, so let's get to the real mystery. What is actually stopping us from building taller? Well, it turns out there are 3 major walls that all these challengers keep slamming into. First up, yeah, it's still an engineering wall, but it's really about raw physics. The taller you go, the weight and the wind forces don't just add up. They increase exponentially. The amount of stress on the base of a kilometer-high building is just astronomical. Our go-to materials, concrete and steel, are being pushed to their absolute physical limits. We need new stuff like carbon fiber, but right now it's just not practical or affordable for a project this massive. But then there's this second barrier, and this one is kind of wild. It's the human wall. Once you start getting up to heights of 1.5 kilometers or more, you run into real altitude problems. The air pressure literally drops. Taking a fast elevator ride to the top could make people dizzy and nauseous, kind of like getting altitude sickness. So you'd have to build these things with super expensive pressurization systems, and you could see goodbye to stuff we take for granted, like balconies or windows you can actually open. And that leads us to the third and maybe the most important barrier of them all, the money wall. We're talking about price tags well over $1.5 billion. It's a huge financial gamble. And to even get a project like this off the ground, you need this perfect storm of a booming economy, a city desperate for global attention, and a government willing to back it all up. See, this really gets at a huge shift in why we build these things. Back in the 20th century, skyscrapers were a practical answer to a problem. Cities like New York and Chicago were exploding and needed more space. But today, megatalls like the Burj Khalifa are a different breed. They're national symbols, built to put a city on the map, or, like in Dubai's case, to help diversify an entire economy. And those specific conditions, they're incredibly rare. In fact, it's not just a matter of money anymore. Some governments are actually putting their foot down. China, which used to be the world's hotspot for skyscraper construction, has now basically said no more to buildings over 500 meters. They're arguing that anything taller than that isn't practical. It's just a vanity project. But just when you think you have it all figured out, listen to this. Bill Baker, remember, the engineer who made the Burj Khalifa possible? He claims that technologically, we could build a tower more than 3 kilometers high. He says the engineering is there. It's possible. It's not the ultimate barrier. And that leaves us with this one big, lingering thought. It seems we have the technical know-how to reach heights that sound like science fiction. But in a world that's facing so many other, more urgent problems, the real question isn't can we build taller anymore? It's should we? The engineering exists, but do we still have the will?